Hello, good morning, everybody. Welcome to Science and Health Live, our online discussion Q&A session with the researchers who kindly provided videos and lab tours of their showing off their wonderful research. So my name's Keith. I'll be your chair for today. My background is largely in messing around with DNA, human DNA in terms of tissue typing and analysis for immune genes that may be involved in disease pathogenesis, diagnosis, and hopefully cures. So we have a very illustrious panel for you today. I'm just going to try and get everyone to switch on their videos and unmute themselves and introduce themselves. And I shall go around the video streams in order of my screen. So Rosemary, are you there? You're moving around a little bit.
Sorry.
Yeah.
Yes,
okay.
I am here.
Oh, but you're having trouble with your video. Oh, here we go.
All right, there we are. It disappeared briefly.
We've got a few gremlins.
Sorry. Hi, I'm Rosemary. I'm one of the Cardiff University librarians.
Fantastic. Derek Lang?
Hi, I'm Derek Lang. I'm the director of the BSc in Medical Pharmacology here at the Med School.
Cheers, Derek. Jane?
Hi everyone, my name's Jane Renninsteer and I'm the lead for clinical procedures here in Cardiff University School of Medicine.
Fantastic. Thanasi?
Hi, I'm Thanasi Soulis. I teach on the undergraduate program. I'm also the director of the MS in Psychiatry. I lead on mostly the psychological medicine teaching on the MBBCH program though.
James, would you like to say hello? I think you have to unmute, James. Sorry, yeah.
As you think right now, after 2 years, I'd know that. Good morning, everyone. So I'm the chair of the Science and Health group, and I'm also lead for undergraduate teaching in the domain of immunology in the School of Medicine.
Fantastic. Thanks, James. And Alan?
Hi there, I'm Alan Cotter. I'm from the School of Pharmacy. I'm the admissions officer for the department, and I have a research group based around injectable or formulation medicines.
Fantastic. Ian?
Hi, I'm Ian Brewis. I'm responsible for a facility that offers high-end technologies to researchers, and I'm also very interested and involved in teaching bioinformatics, the use of computing in biomedicine.
Wonderful. John?
Hi, I'm John Erickson. I'm representing the School of Optometry and Vision Sciences. I'm a neuroscientist myself, and I work on abnormal eye movements in humans. And although not a clinician, I've been with the optometry school for quite a number of years.
Fantastic. Thanks, John. Rebecca?
Hi, I'm Rebecca Sompresser. I am a Library IT Operations Manager at Cardiff University.
Wonderful. Luke?
I'm Dr. Luke Davis. I'm a research scientist at the School of Medicine studying the immune system.
Wonderful. And I think hopefully you're going to get a lot of questions. I think COVID is still very much in everybody's minds. And finally, Bob.
Hi, I'm Bob Stedman. I'm the senior lecturer in the Department of Nephrology and researching into kidney disease and its progression.
Wonderful, wonderful. So the way things are going to work is that we've done Thanasi, I think. Yeah. Did I forget anybody? We've got a few gremlins creeping in. I don't think I did. Fantastic.
We've got a couple of new, I see one face at the bottom of my screen. Who's a co-worker with Bob?
Oh, is that me? Dan?
Oh, well, I've got Bob Stedman on my name, but that's not my name. Bob sent me the link through, so let me see. I don't know if I can even change my name, to be honest.
Thanks, Dan.
Oh, I can, yeah. All right.
Brilliant. Okay, well, please chip in if you feel the need. So, and Karen, why not? Let's give Karen a big welcome as well.
Sorry, Keith, can you repeat that, please?
Yeah, I just want to say, can you introduce yourself? Say hi.
Oh, sorry, I can't hear what you're saying, Keith. Sorry, hang on a second.
Oh, don't worry. Karen is behind the scenes and keeps us all organised and has done an absolutely wonderful job of getting this thing moved from face to face to online. Okay, so let's see if we have any questions coming through then. This is the idea. What we would really like you to do is ask questions about any aspect of the research videos you have seen, anything aspects of current science. We'll try and field many of those. I don't know, do we have any questions coming through yet, Karen? Do you know? Can you actually hear me?
Keith, I'm not sure Karen can necessarily hear you at the moment. So
right.
I know that this is being recorded. So maybe we could ask the panelists just to tell us a little bit about their field, their work, and the challenges they might have experienced over the last couple of years. Something on those lines. Leave it to you, Keith.
Yeah, I wonder, I mean, obviously the elephant in the room is the COVID pandemic situation. And I know Luke's team did a wonderful presentation on their involvement with actually combating that. And what I was struck with by was looking at the videos was that the kind of sense of dejection, the sense that we were at war this time last year. And I think hopefully the mood has changed. Luke, would you like to update us on what's going on with your research?
Yeah, so first the caveat is that I'm not a viral epidemiologist or expert in particularly in viral immunology. So there are big hitters in Cardiff who do that work, such as Dr. Richard Stanton, who have recently received acclaim and won awards for doing that. So that's the caveat for my research. I work on sepsis. So with COVID-19, you have a strong host response to virus, which results in a disease which unfortunately is fatal in many people. And so that disease, even though we call it COVID-19, it's a type of viral sepsis. So I work on sepsis, primarily bacterial sepsis, because that's the main one. But because of COVID-19, of course, we are now getting many cases of viral sepsis. But what's interesting about COVID-19 is that we seem to, the response to virus seems to be wrong in this disease, and it seems to think it's more, it doesn't really know it's a virus because we had at the beginning of the pandemic no immunity to it whatsoever. So that's why it was so fatal. And my job really is to, in this disease as well as other types of sepsis, to look at the white blood cells of the immune system and see what contributions they're having, not only to trying fighting the virus, but what they're doing in terms of damaging the host. And that's essentially what the problem is in sepsis and COVID-19, is that your white blood cells will be trying to fight something. They're not very specific, and they will end up damaging your own tissues. And this is where you get organ dysfunction in sepsis and COVID-19. So yeah, during the pandemic, of course, we've had a dramatic shift towards viral work, which has been great. But it has, because of the pressure on hospitals, it's really put pressure on doing clinical research. And during the early days of the pandemic, this was, sort of a bit limiting to the research. But now, it's starting to kick back in. A lot more effort going on in terms of COVID-19 research. We know more about this virus than we know about any other virus. That is for sure. Almost you could say that we know more about this virus than we know about any other disease in general, because there's been that much research put into this. But the good thing for my field, sepsis, is that because this disease, especially in the early days, caused that sepsis response, it's really made us learn a lot about how different cells respond and can trigger sepsis. And for COVID-19, it's because the virus sort of cloaks itself, and it has specific mechanisms to do that. And usually, we evolve with viruses and we're capable of fighting that off. But when something new comes along, which we're not really sure what it is, this is where the problem is that the body senses it, sends out the wrong signals. Instead of saying, oh look, we got a virus, let's destroy the virus and recruit cells such as natural killer cells to come in and sort that out. They're saying, we've got a problem, we don't know what it is, send in your big hitters, which are your neutrophils, white blood cells, and macrophages. And then these set off, a massive, sort of cytokine storm, cascade of signals, which then cause tissue damage. So, now we're, with this virus, we can get sort of insights into how, viruses can trick the immune system, but also, how would bacteria do the same thing? Why in normal sepsis scenarios would that happen? And I think, with all the studies coming out on COVID-19, that's really sort of pushed forward the field of sepsis research as well.
That's brilliant, thank you. I mean, that all kind of links into a question we've had. I mean, I'll just quickly ask you whether there's any genotype, any particular character trait of the people who are susceptible to cytokine storms and this kind of auto dysfunction, this over immune reaction. Is there any genetic link with the people who present like that?
So this again it's really complicated, but certainly during the early days of the pandemic, there was a receptor called ACE2, which is the receptor which is on many cells in your body, which the virus spike protein uses to get into the cells. And certainly there are different expressions of ACE2 regarding genetics, but actually the main differences with ACE2, it comes with age. So when you're very young, you don't have much ACE2 on your cells, therefore there's less chance the virus is going to be able to infect you. Whereas when you get older, the ACE2 expression increases on your cells, and then there's more chance that a virus is going to affect any given cell. So that's been the main sort of risk factor, is age in the pandemic. But certainly there are differences between different ethnic groups when it comes to ACE2 expression. And for instance, when the pandemic first kicked off in China, there doesn't seem to be as I'm not sure of exactly of the genetics, but the ACE2 expression was not as much of an issue over in China. But when it came to Europe, it started to mutate very rapidly in I think it was the Italy skiing season when it started to change. And then it hit the European population quite hard. But certainly there's difference between groups when it comes to ACE2. But when it comes to sort of every aspect of how not only we respond to the virus, but also how the virus binds, the genetics will change there. And one of the things to sort of come out of the host response was differences in the interferon genes. And there was, sort of polymorphisms, which are single codon differences in the interferon genes, and there's different types of interferon genes, but some of those changes actually had a negative impact on responding to COVID-19. You weren't able to produce an effective interferon response, and so this is not specific ethnic groups here. This will just be on an individual basis whether you have an allele which is sort of susceptible to COVID-19. I think that early research was quite promising, and now I think that's sort of being, it's so complicated that if you have that allele, you might be more at risk, but then you might also have a different gene from a completely different pathway, which then gives you more protection. So then it evens out. So even though we've researched this virus at extremely high level, we still have a lot to learn, and there's a lot more room for research here.
I couldn't agree more, absolutely. I mean, I think, as you said, one of the most amazing things about the last 2 years is how the scientific community has come together internationally, not just in the UK, and how quickly a vaccine program can be rolled out if absolutely necessary. So I think if anyone is concerned about the current increases, we're in a much better position to deal with any increases now than we were 2 years ago. So yeah, the question really was about gene therapy and personalised medicine. Does anyone have any insights on what's going on in Cardiff in that respect? Anyone involved in any of that?
Dan, would you like to come in? I see you posted something.
Yeah, it looks like Dan's answering.
Yeah, I mean, I'm not I don't work in gene therapy or anything. So I was just sort of putting something on my end. So yeah, I don't do the gene therapy thing, I'm afraid. That's not area. I do know that personalized medicine is obviously something that we're all, it's one of those key hot words that we're all looking for at the minute. My work specifically doesn't go necessarily into that, because I'm, as some of you may or may not know, and if you I'm not sure if it's mentioned in the videos that we put up or not, but I work on trying to develop a dipstick biosensor, so as like a diagnostic tool for specific diseases in individuals. So it's not necessarily personalized medicine, but what I'm trying to do is look for small things called microRNAs, which are like small RNA molecules that are given off by diseases. And then by knowing which specific RNA is specific to that person, we can better diagnose their disease. So not strictly personalized medicine, certainly in that field. But yeah, I was just putting in an answer because yeah, we were talking at the time.
Fantastic. You're more than welcome.
Another thing to point out here is that one of the new vaccines to come out for COVID-19, the new technologies has been gene therapy. Essentially, you put in some of the viral RNA into sort of a plasmid, and then you send it into people, and then this gets into the body, and your own body then turns this into protein. So this is certainly gene therapy, and doing this on this sort of scale and seeing the safety factor of it as well. It's been 100% safe, so pretty much 100% safe for everybody involved. And this doesn't have to be specifically used for vaccines. This sort of technology can be used to introduce proteins into people who may be lacking certain proteins. And the fact that this vaccine was able to be given to so many people, we have all that safety data now, really pushes on the field of gene editing on a personalized medicine basis.
Fantastic. Yeah, I mean, genomic medicine is something that I've been quite interested in over the years, and I think there is no doubt that this is the direction in which medicine is moving towards, trying to tailor treatments to an individual. However, that is expensive. That's very expensive, and medicine really works on a population level. We really have to use population data in order to design interventions on a, for the NHS on a kind of UK scale. And I think the other thing to mention is that often many of these genetic diseases are quite rare, and so personalised medicine requires personalised medicines. And so they are obviously quite expensive to produce in small numbers. So although the direction of travel is clearly in personalised approaches to medicine, we really do have to kind of think in terms of strategy on a population level. What are the most common diseases? Where can we have the most impact? Where is the biggest bang for our buck, I think? So I think we have another question here. So when COVID research is talked about, is that focused mainly around the vaccine? If so, now that vaccines have been discovered and introduced, has the amount of COVID research reduced? I don't know if anyone want to take any of that. I'd quite like to move on a little bit from COVID, but I think that if anyone's got any comments on that.
Could I just, sorry, Keith, just to add to the previous question, if that's okay, just a brief.
Sure.
So, like Daniel, I don't work in that area of personalized medicine, but I know that in psychiatry and in our division of psychological medicine, there is a lot of research currently taking place into epigenetics, pharmacogenomics, and the application of that to personalized medicine approaches for conditions such as psychosis. And I know that some of our more senior medical students have got involved in that as part of their SSCs, their projects in year 4, I believe. So there are opportunities for students to explore that further, at least the research components of that within certain research divisions. And I don't want to go back to COVID, as you say, Keith, but I ran a project during the pandemic on the impact of the pandemic on individuals with OCD, specifically contamination-related OCD, and I had a wonderful group of year 2 medical students actually work with me in analysing the data. So there are opportunities to get involved in research as a student at Cardiff, and I imagine everyone, all my fellow panelists will agree that that's something we encourage our students to do as well.
Absolutely. I mean, it might be worth mentioning that all our DNA is 99.9% the same. I mean, that's still probably about 1 million bases variation between individuals, but we are 99.9% the same. So, so we move on from COVID then. I mean, we did have this question about COVID research. Is anyone actively engaged in COVID research still, I wonder? Apart from Luke, I mean, I know Luke is, but is it some of you? I know some people in Cardiff turn their labs over from cancer research, for example, to COVID research. But no.
Yeah, there is.
Sorry, Alan, do you want to come in?
Yeah, it's not directly on COVID itself, but it's about patients being impacted by COVID. So we've been doing work with Cardiff and Vale about patients who would traditionally have come to hospital for treatment, but because they may be immune suppressed, so cancer patients, then we've been working with the manufacturing unit about making sure drugs could be stable in medical devices, and then we could supply those to the patients for their treatments at home. So there's already this movement in pharmacy to try and get patients treated in their homes. It's more beneficial for them. And obviously COVID helped drive that. So we've been doing it on a number of drugs associated. That started out with student projects. So students doing the background research, and then some of them joining our labs or us taking over that lab work to actually analyze the drug. So it's related to COVID, but not directly on COVID itself.
Brilliant. So, does anyone know what the therapeutic options are for COVID now in terms of like actual medicine? Because I remember I did a quick Twitter survey when the pandemic first started about who would like a vaccine and who would like a cure, and most people wanted a vaccine at that stage, which I didn't really understand because there was clearly vaccine deniers around even then. And I thought that in medicine, we should channel our funds, our research funds, into actually developing a cure rather than a preventative medicine. Anyone, any thoughts about therapeutic options? No, I think, was it there's a steroid, wasn't there? The dimethylone.
Dexamethasone has been used, and they're looking at some of the MABs, some of the monoclonal antibodies are coming forward. So those are quite expensive, though. That's the thing.
Yeah, that's another very good point. Yes. Okay, so let's move on from COVID then. Forgive me if I'm missing hands going up. I'm trying to field questions as well. I think we have another question for Derek, perhaps. Could the panel discuss if possible, what research is taking place to develop new drugs to combat antibiotic resistance? Good question and very pertinent. I think Mark's not here, is he? Mark's Holman would be good. But Derek, do you want to take that?
Yeah, I won't be very good at all, I have to say. I was just typing, hi Martin, nice to hear from you. Haven't seen you for ages. I know that there are definitely a lot of projects on antibiotic resistance going on within the school. Some of our students are getting involved in that with their final year projects, for example. The topic is covered in our year 2 and year 3 of the BSc course, but specifics, I'm afraid, even though it's pharmacological, my pharmacological brain doesn't reach that far, I'm afraid.
Anyone else want to come in on antimicrobial resistance? It's a huge topic. I know that luckily it has been funded in Cardiff fairly well and really generously at the moment. No, maybe I'll just comment then that, in terms of genomic medicine, I think a lot of people think of genomic medicine, personalized medicine as being about the patient. A lot of it is obviously about the genome of the bugs as well. So I'm fairly optimistic. I know that Mark Tolman's lab is looking at phages, which are these viruses which attack bacteria. And I think the future's bright on that in that respect. Jane, would you like to talk about anything?
Yeah, so hello everyone. So as I said, I'm Jane, I'm the lead for clinical skills, and I'm actually quite lucky in my role. In fact, I shouldn't say this, but I've got one of the best jobs in the School of Medicine, because throughout the pandemic, even though initially we were all quite apprehensive, we actually maintained all of our face-to-face teaching with our students. I know many of you within schools, you unfortunately had to go online with Zoom and Teams, and it's probably the reason why I'm not very good on Zoom and Teams now, in that we never had that. We always maintained that our medical students stayed face to face. We obviously kept them very, very safe throughout the pandemic. But what we teach here in clinical skills really is the hands-on element of what being a doctor is all about. And we're also very fortunate, and even though we're the School of Medicine, we also do a lot of interprofessional education, and we have very, very strong links with the pharmacy students, so that the pharmacy students and the medical students learn from each other from a very early stage. And we also have the speech therapy students come with us, and also nursing students. So it's a really collaborative sort of approach to education. And what we teach here in clinical skills is those hands-on skills of what being a doctor is really all about. And so it's a really sort of interesting area, and that's why I'm very lucky to work here. And you start to learn hands-on clinical skills really within the first few weeks of starting medicine. So if any of you are interested in medicine and you come onto our course here in Cardiff, I really look forward to seeing you very, very early on within your course.
Absolutely, thanks, Jane. Yeah, I think that is one of the big selling points for studying medicine in Cardiff, is that you get patient exposure and clinical skills exposure very early on. Come on, is any students out there, please do ask us questions. That's what we're mainly here for. And I guess encourage you to ask any questions you like. We'll try and our best to approach them.
If there was a question about what Cardiff University might be looking for in an undergraduate student.
Yes, sorry, yes, I know that. I'm happy to, we can discuss that if you like. I was just going to recommend that the admission type questions were saved for your session, but more than happy to discuss that.
As a generic question, maybe the panelists might be able to give some thoughts on what maybe John, you might be looking for down in School of Optometry, and what others in different schools might be looking for in their undergraduates.
Yeah, I mean, we tend to look for people who've had a couple of science A-levels, and we do have a prelim year for those who make the decision to pursue this career later on and only have one science or no more than one science. And we no longer include psychology or sociology as a science, which seems a bit unfair, but that's the way it is. But, you know, biology, chemistry, physics, that sort of thing. So 2 sciences is what we tend to look for. And as I say, we have a prelim year for those students who don't have that, but are thinking of optometry as a career.
And what makes a successful undergraduate for you, John?
Oh, I think a commitment to working with people. I think, you know, as Jane was saying, what you know, in the case of an optometrist, what an optometrist is all about is helping people, surveilling disease, having the requisite amount of knowledge and expertise. So we're looking for somebody who's committed and wants to learn and has a very professional attitude, you know, something that they'll probably partly develop in the course of their undergraduate career. So I think we're just looking for somebody who's enthusiastic about all aspects of medicine, and in the case of optometry, eye health.
Any other comments about admissions? I think we don't really want to discuss admissions too much if possible, but yeah, a medical student, ideally you need to show willing, and I think a lot of you guys already, by turning up today, will have something to talk about at interview. You know, in Cardiff we run these multiple mini interviews. And so you have engaged with the medical school already. So that just shows initiative. That's kind of what we're looking for. The other kind of tip is personal statements. Please write them yourselves. You know, we're very good now at spotting ones that have been written by a factory or bought online. So it's just, we're looking for genuine people who have a genuine passion and enthusiasm, both for studying science and humanities. Medicine is a wonderful mix of science and the humanities. So we're looking for people who are, you know, independent learners, people who have empathy, and you know, more and more I've noticed that our students this year, they really do want to try and make a difference. There was perhaps tendency pre-COVID that these were bright young children, bright young students looking for a solid career, which medicine obviously is as well. But I do get the impression that our first, particularly our first years, having been through the pandemic, see there's an opportunity to really actually contribute, and that's really encouraging to see. So as I said, we do have an admissions panel later on, so hopefully we can deal with more of the niceties of which A-levels that you need and at what grades. But largely, you know, if you can turn up having shown willing, like showing some working in an old people's home, any work experience you can get that's even vaguely relevant, just shows that kind of like desire early on. Okay, so I think we have a new panelist. If anyone has any questions for Sarah Yude, who's from the dental school and on tissue culture, we'd be more than welcome to field those. I see that we do have some more questions in here.
Keith,
So,
a couple of people had their hands up. I noticed Dan and John. And
I'm so sorry. I'm not very good at the hands thing. Dan, did you want to come in?
Yeah, sorry, I was just going to jump in. Obviously, I'm not in the admissions thing later, but it was more a future question because some questions might get asked of, once you say, I want to be this, this, and this. I just want to say, because obviously, when you're coming out of college and you decide, you want to be a pharmacist or a doctor or a chemist or a biologist or whatever it may be, don't feel like if you have an idea of what you like to do, be it if you're medicine, that's what you're gonna do. If you like a little bit of chemistry, you might like biology, but do what you enjoy, do what you're good at and what you enjoy doing. But I will say, as someone who's done it, it's very easy. If you do an undergraduate in chemistry, for example, like I did an undergraduate in chemistry and I did a PhD in chemistry and medicine, and now I work for the School of Medicine. So it's very easy to, once you're in the university, even if you, if you start off as a chemist and then decide actually you really quite like biology and medicine, you can move into that field later. So don't be panicking now as an A-level student about what you must do for the rest of your life, because they'll tell you that you should have an idea of where you want to be in 50 years time. But focus on what you're good at now and what you like to do. And if it doesn't, if it doesn't work out quite your way, it's not game over. There's a lot of different routes once we get into university. So I just wanted to put that forward, specifically obviously for the medics as well, because should they not necessarily get the A-levels that they need for medicine, that's not game over either, right? If they go into particularly in Cardiff, they go into biomedical science or pharmacy, they can go in as a graduate afterwards. It's, there's other options there. So it's just an alleviation of the worries of A-level students. But
wonderful, yeah, I concur entirely. I think another thing perhaps to mention is that in life sciences degrees, medicine, whatever they be, usually have a lot of transferable skills. If you do get to the end of 3 years and you think, didn't quite enjoy that as much as I thought I might, you learn a lot of stuff which can be applied to other avenues of interest. So we have a question about pharmacy, and I think there's a student here looking to get into pharmacy. So I wonder whether Alan and or Derek could help us out with that. What we're looking for in pharmacy students and latest developments and research in this area.
Okay, so as the admissions officer at school, so basically a lot of things that John mentioned about optometry apply to pharmacy. We do have an interview process. One of the things to comment of is we get a lot of students who overlap between medicine and pharmacy, maybe using pharmacy as a backup. The one thing there about is the personal statements. Your one on the UCAS form ideally should be targeted purely to medicine, and then we will ask for a separate personal statement and work from there. The one big development in pharmacy is actually at undergraduate level, and our training year is that in the future that all our students are going to have the ability to prescribe, be independent prescribers. So we're in the current process of adapting our course. At the end of the 4 years at university in our training year, those people will have the ability to prescribe, whereas at the moment it's a postgraduate qualification. So that's where the changes is happening. So we're still scientists, but we need scientists who can apply that knowledge in the clinical setting, as it were. So that's where the biggest developments are taking place for us. But many of the students overlap, I say, a lot with medicine. And I think your comments about getting any type of experience during the pandemic, that's been very difficult. But it's not just about standing in that environment. It's what have you got out? What have you seen? The communication between team members, many of the healthcare systems are that. So, and then applying your own transferable skills from sport, music, drama. Can you use that in an interview setting? So that's what I would say really about pharmacy.
Thanks, Alan. Do you want to put the pharmacological perspective, MedPharm, Derek?
I'll pick up on something that Dan was saying earlier on. I did my BSc in zoology and then did a PhD in pharmacology, and now I'm a professor of pharmacology. So I've had a very different route to that, I suppose. In terms of students, we'd like students to know what pharmacology is for a start. That's always a good thing. Enthusiasm, insight, curiosity is a huge thing. You like to know how things work. That's what we do in pharmacology, really. Another thing, as Dan said, in terms of medicine, we get a lot of applications, probably almost half of our applications from students that put us down as their 5th choice. So they're applying for 4 med schools and then put us down as 5th choice. We have a lot of students then that come to us with a view to doing medicine afterwards as a grad entry. So there's an accelerated grad entry program at Cardiff and North Wales. So yeah, we do manage to persuade people that medicine is not for them and they should become scientists, and they go off and do PhDs in Australia and all sorts of things. So yeah, the world is your oyster, really. So certainly don't be constrained by your teachers telling you or your parents telling you you have to be a doctor, because that's the thing to do. Do things that you enjoy yourself. I totally agree with that.
Yeah, I'll endorse that as well. I mean, if that's always a head start. If you find it naturally enjoyable, then you're not going to find all the coursework too onerous. You know, if you're doing a subject for the sake of it, for like peer pressure or whatever, and you're not naturally finding it very interesting, it can become a chore. So that will be, look to your gut, look to your brain, and come up with what would you like to know about? What would you like to study? And I understand, life sciences do merge together slightly. Which particular life science would you like to study? So perhaps that's where you should focus your research on, what aspects of the life sciences actually appeal to you. So we have a question around the brain and the music, which I've also found particularly fascinating. I did a little bit of work on this myself. So Rosemary, I don't know whether you'd like to come in and I know you're planning on doing a little presentation at the end. Would you like to comment on how the brain, has there been any further studies in this area? What would you like to say about music and medicine?
Well, I'm not sure that I know very much more than what we said in our presentation, really. Perhaps I could just give a bit of background to this. The stand that we have done every year for many years in Science and Health Live is always done by some members of the Cardiff University library staff. And originally we tried to have a library related theme, and then we decided that wasn't terribly interesting. So we've rather branched out into completely different topics. So last year we did sleep and the benefits of sleep. We've done something on plastic and pollution, that kind of thing. And Nigel, who's one of our group who can't be here today, is a very keen musician in his spare time. So he was very keen to do something on music this year, which was why we chose the topic that we did. We always end up doing an awful lot of background research on our topic, and we collect huge amounts of information that we just don't have time to use. So we enjoy it tremendously. But I'm not sure from the scientific and medical point of view what research is going on, if any, at the moment. So I don't know if anybody on the panel has got any thoughts on that.
I'm not up to date with the current research, but I agree. I was just typing an answer in there from a kind of a neuro perspective, that it is fascinating the impact that music has on the brain. You've got parts of the brain that are responding to the auditory cues, the stimuli. You've got parts of the brain that are sort of interpreting the lyrics, and what that may mean to the individual. You've got parts of for instance, the limbic system responding to the emotional component. It's just a wide network of regions within the brain that are responding, and it just illustrates what a powerful, maybe this is a bit of a, I don't know if I should use the word organic machine, but just how powerful the human brain is, taking information and processing it in such a way that you find meaning in something, both I suppose in the cold cognitive as well as an emotional, just from a cold cognitive and emotional perspective as well. So yeah, I think it's difficult to narrow it down to one specific part of the brain. You've got parts of the brain that are responding to the reward aspect. You've got parts that are responding to the meaning behind the lyrics. It is fascinating just how the brain responds as a whole to something, as simple as a song that comes on the radio.
Yeah, sorry, Derek, do you want to come in?
As a follow-up to that, it's not something that's actually done at Cardiff, so perhaps I should mention it, but I teach in the first year of pharmacology an introduction to pain and migraine. And there's a study that came out recently that people that when they're having a migraine, if they reminisce about happy times, that had a positive effect in alleviating the pain of migraine. So that talks to what Thanasi was just saying there about the mind being a very powerful thing and thought being a very powerful thing. But yeah, I don't know any more about it. I just thought that was something that was really clever and interesting.
Yes, sorry,
I was going to say that's very interesting, because I do suffer from migraines myself. So I'll find that study and I'll read it with great interest. So thank you for that.
Yeah, apparently, if you play music during an operation, you can actually reduce the amount of anaesthetic required, which reduces recovery time, which has a positive impact. Yeah. And my understanding is that, in the States particularly, nurses, etc., anaesthetists will choose their rota on which surgeons are operating and what their playlist is. And I guess the other thing that doesn't come across is that surgeons that play music themselves are often better. They're more dexterous. So the music has an impact at all levels of medicine, really. Yeah. Fantastic. So
I think Charity's wanting to come in, Keith.
Sorry, Charity. Hi, welcome.
Yes, I'll be giving the presentation for the library later on, talking more about emotional response in the relation to music and some of the research that's happened. But just for the students who are here, this is one of those exciting moments of interdisciplinary research where you will find people within medicine working with musicologists, working with field ethnomusicologists, and just to big up how important and exciting libraries are. We're the gateway to that information. And if you don't have access to an academic library right now, your public library will at least have Musicophilia by Oliver Sacks that talks about the relationship between music and treatment of Parkinson's, dementia. It's such a wonderful field to look for, and so many different points of exploration. It's a fabulous example of how topics can intersect. A great sort of example in the library is that we have a book about music and psychology, and it's within our music section on the top floor of our Arts and Social Studies library, and it's in the bottom floor as well with our psychology section. So I think there's just so much exciting potential to think outside of the box and to find collaboration and partnerships, and in terms of what's happening now with scholarship, partnerships and that collaboration, really exciting. That's the librarian's perspective for you.
That's amazing. What an injection of energy that was. That's fantastic. Brilliant. Thank you so much. It almost kind of brings us full circle, because the last question we have is really about mental health during the pandemic and what we can do going forward. And I imagine music, I would recommend music as that's what my go-to. I think music has become much more important. I don't know about you, but lyrics somehow seem to mean an awful lot more nowadays than they perhaps did pre-pandemic. Anyone like to comment on mental health? I mean, Thanasi, have you got any insights on I think we have had a panel yesterday on school-aged children and mental health going forward after the pandemic. Anyone, any comments?
I think it's a really good point. The research sort of exploded during the pandemic in relation to the impact that lockdowns were having on mental health in different population groups. Obviously, we were looking, I alluded to our research previously looking at OCD, but even when you're looking at non-clinical groups of participants, for instance, young people have been very much affected by the pandemic. The disruption to schooling and also the disruption to their social lives. That was a major concern. I think it's probably a little bit naive for us to think that we're out of the woods now and all this is in the past. I think we're looking at a kind of, if we can be ambitious enough to say, a post-pandemic impact, but there is going to still be an impact on individuals' mental health. For instance, those who have an element of health anxiety, we see that now they're feeling rather anxious about going out potentially into shopping centers without anyone wearing a mask, you know, and that is something that by law people don't have to do now. But individuals with health anxiety will be thinking, well, you know, I don't feel safe in this kind of environment. So there is this kind of period of transition, I think, where individuals are still feeling vulnerable, especially individuals with this element of health anxiety, and that can have an impact on how people feel in this period where, you know, the rules are being relaxed. So I think the mental health aspect has not gone away. It's definitely something that we are still going to see having an impact on young people as well. It's something that I think the research is adapting to now. It's adapting to the changing circumstances. It's not necessarily just about the impact of lockdown on mental health, but the impact of this kind of transition to a new kind of normal on mental health.
Absolutely. I think you may have, oh, you haven't frozen. No, I thought you had for a minute. Sorry, Tanasi. Yeah, and the other thing I think we will agree, but, you know, mental health is really, it's a yin yang thing with physical health. And one of the things about music, obviously, is dancing. And so, like, you get the benefits of both with music. It gets a mental workout and a physical workout if you dance. So on that note, I hope you students out there will be dancing. And I shall hand over to Rosemary and to Charity for the Music of Medicine and Science exhibition. Is that okay?
Yes, great. Thank you very much, Keith. As you know, I'm Rosemary, and I hope that you enjoyed our presentation on music, which you were able to see last week, I think. And we did want to give you some practical examples. So we've enlisted Charity, one of my colleagues who you've just met briefly. So a little bit of background about Charity. She hails from Los Angeles, but she now calls Wales her home. She has a BA degree in voice and composition and a master's degree in library and information science. She was raised in a musical family and has been performing since the age of 3. And in addition to the formal training she received during her BA degree, Charity has also sung with several choruses, with appearances at Carnegie Hall, St David's Hall, the Hoddenot Hall, the Royal Albert Hall, and the Théâtre des Champs-Élysées. And she has served as music librarian for Cardiff University since 2007. So I hope we're going to hear from her now. And over to you, Charity.
Good morning, everyone. Okay, I am going to share my screen for my presentation, and I really hope you enjoy, and I'll try to go quickly so there's time for any questions you've got at the end. And sharing my screen. There we go. Okay, so I am here to talk about musical examples for the relationship between music and emotional response. Music is comprised of different elements. How these elements are defined varies, but for today's purposes, I'm going to discuss pitch, which is how high or how low a sound is. Rhythm, is it smooth or is it bumpy? Tempo, is it fast or slow? Dynamics, loud or soft? Timbre, gentle or brash? These elements are brought together and come to life through performance. And when there's the additional element of lyrics, that can also be part of the overall picture. My first examples are going to involve just pitch and how pitch itself can sometimes create an emotional response. And right, whether or not you're a fan of The Simpsons, those sounds might have brought together instant associations. In Western art music, we call that a minor third, the relationship between those two notes. Now, some of you might have felt a bit tense. Some of you might have gone, ooh, I don't know, or maybe you thought of old playtimes, and that's because some research has indicated that around the world in multiple societies, that those notes are used for taunting. Na, 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 na. They can also be used for games. Seesaw, Marjorie Daw. But if you use the notes in a different direction, where they ascend from lower to higher.
Hi, Charity.
Yes?
Sorry, can I jump in a sec?
Oh yeah, is it not sharing?
It's when you share,
Okay.
you have to do the checkbox to say share sound. The sound's not coming through.
Okay, let me just check my video settings. Sorry about that. And under audio. Yeah, and where am I looking?
It's when you first did the share your screen. So if you stop sharing.
Okay. Right.
Oh, yeah. Well, no, that's for the smell. If you stop sharing, then when you do share, there's a little checkbox in the bottom left-hand corner that says share sound.
Let's see if I can do stop. It's saying, here's stop share. Apologies, everyone. Okay, and let me do this again. Share.
And in the bottom left, there should be a little checkbox to say share
sound. Brilliant. Perfect. Thank you so much.
You're welcome.
Okay, so what you didn't see was a video of Nelson from The Simpsons, and I can find it right now. Nelson, Simpsons. This is real library work for you. You know, this is the heart of librarianship. Okay, so here's The Simpsons. And there we go. Now this should hopefully make a bit more sense. Okay, so that is Nelson from The Simpsons, and here's that minor third again. Seesaw, Marjorie Daw, or nee, 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 nee. So that combination of pitches it does resonate throughout multiple cultures with childhood memories. Sometimes a bit, memories that are a bit tense. However, if we do the ascending minor third, you might suddenly feel a sense of calm. Perhaps you'll even recognize lullaby and good night and with roses bedight. Now, there was a research group that put together what's called the Natural History of Song. This is a research project investigating the universality of music. What they did was they, using 29,000 volunteers across 30 geographical regions covering the globe, they shared recordings of music from 315 societies. And believe it or not, initial findings do indicate that no matter where you come from, no matter what language you speak, no matter where in the globe you are, most people can recognize a lullaby. So that's just a little bit of food for thought on how pitch might create certain emotional responses just automatically. Now that research is still in its infancy. The initial findings were published in 2020, but I'll give you the website to look into, to visit their research more at the end of this presentation. Okay, so that was just pitch. Let's look at the other examples of rhythm, tempo, dynamics, and timbre. So what I'm going to do is I'm going to sing Twinkle, Twinkle, Little Star, but I'm going to sing it as a lullaby, as a taunt, and then also as a piece of Western art music. And what I'd like you to think about is how all of those different elements might create an emotional response for you. So first I'm going to sing lullaby. Twinkle, twinkle, little star, how I wonder what you are. Okay, so I used a very soft dynamic. I used a gentle timbre, and I used a rocking rhythm with a sort of moderate tempo. Right, now let's listen to it as a taunt. Twinkle, twinkle, little star, how I wonder what you are. So for that, I used a much faster tempo, a harsher timbre, and a sort of even rhythm. Now, if I were to elaborate and make it go even, go for the whole song, I might even start using spoken words. Up above the world so high, like a diamond in the sky, to highlight certain words. And I'm going to do a little more about highlighting the words in the art song version. Forgive me, I've just come back from the school run and I haven't warmed up my voice yet. Okay. Twinkle, twinkle, little star, how I wonder what you are. Now, this element, but I set it at a higher register so that I could bring my voice more. You can also see that I've changed the dynamics. I had a bit more freedom with the tempo, and I used my pronunciation to highlight certain words. So you might have had a different association then, where even though the pitches were the same, by using these different elements, you present a different, if not an emotional response, at least associations. Of course, most of the research about emotional meaning and music, it is very much seated in your own prior experiences. So we've looked at pitch, rhythm, tempo, dynamics, and timbre, and I've performed these things for you to bring them to life. Let's look at that final component of lyrics. This time, I'm going to use everything all the same. The timbre is going to be the same. The rhythm's going to be the same. Dynamics, all of the pitches, all completely the same. But I'm going to change the lyrics and have a think about how this might change the associations for you. So I'm going to sing Twinkle Twinkle again for you, but I'm going to sing it 2 more times now with different lyrics. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Right, so whereas Twinkle Twinkle might bring a sense of relaxation and calm, perhaps an association with nighttime, the alphabet song will probably bring to mind memories of being alert in the daytime, being focused on learning. It might have a sense of more structure. Now, what about the associations if I sing it with these lyrics? Ba, ba, black sheep, have you any wool? Yes, sir, 3 bags full. Now that song, depending on when you heard it as a child, you might feel an association with the day or with the night. But what it will bring to you that isn't necessarily as closely associated with Twinkle Twinkle Little Star or the alphabet song is that it's story-based and it has much stronger visual representations from the words. Okay, so that was just a little bit slices of musical examples. If you'd like to explore further, I do recommend looking at the Music Lab, www.themusiclab.org. This has games to play, as well as all of their papers, including some preprints. So if you would like to learn more, please have a look, and thank you very much for your time.
Fantastic. Thanks, Charity. Yeah, a round of applause. That's the injection of energy I needed, I think. But thanks so much. Music is so wonderful to play and to listen to. I think it's a win-win situation. So guys, it just reminds me to just thank you all for attending, and for you students out there, please do apply for medicine and life science research, life sciences degrees. They are the best in my humble opinion. If you're a bit more artily inclined, as I say, medicine is a combination of science and art, so perhaps that will suit your needs. But all the best. Just show some enthusiasm at interview, and I hope to see you lot in Cardiff in the next coming term. I don't know whether you have any closing comments, James?
No, that's great, Keith. Thank you very much. Yeah, that was excellent.
Yeah, thanks everyone, and I hope to see you again next year on site. Thank you very much. Cheers. Bye.